Water is the lifeblood of our planet. Every living thing, from the smallest microorganism to the largest whale, depends on it for survival. Clean, safe water is fundamental to public health. We need it for drinking, cooking, sanitation, and agriculture. Without water, human civilizations would cease to exist. Yet, despite its importance, water resources around the world are under increasing threat from pollution. Industrial discharge, agricultural runoff, and untreated sewage are just some of the factors that compromise water quality. Protecting our water sources is not just about safeguarding human health, it's also about preserving the delicate balance of aquatic ecosystems. Polluted water can decimate fish populations, destroy coral reefs, and disrupt entire food chains. The consequences are far-reaching and often irreversible.
Monitoring the quality of our water resources is essential to identify and mitigate pollution. This involves analyzing various parameters, some visible to the naked eye, others requiring sophisticated laboratory techniques. Physical parameters offer immediate clues about water quality. Temperature, for instance, directly affects the amount of dissolved oxygen in water. Warmer water holds less oxygen, potentially stressing aquatic organisms. Turbidity, a measure of water clarity, indicates the presence of suspended particles like silt, clay, or algae. High turbidity can block sunlight, hindering the growth of aquatic plants and affecting the feeding habits of fish. Color, too, can be revealing. While naturally occurring organic matter can impart a slight yellow or brown tint, unusual colors often signal pollution. Industrial discharges may cause a rainbow of hues, each indicating a specific type of contaminant.
Beyond the visible, chemical parameters provide a deeper understanding of water quality. pH, a measure of acidity or alkalinity, is crucial for aquatic life. Most organisms thrive within a narrow pH range, and deviations can be harmful. Dissolved oxygen is another critical parameter. Fish and other aquatic animals need oxygen to breathe, and low levels can lead to suffocation. Nutrient pollution, primarily from fertilizers, can trigger algal blooms that deplete oxygen levels, creating dead zones in our waterways. Heavy metals like mercury, lead, and arsenic pose serious threats to human and environmental health. These toxins can accumulate in fish and shellfish, posing a risk of poisoning for those who consume them. Organic pollutants, including pesticides, herbicides, and industrial chemicals, present another challenge. These substances can persist in the environment for years, contaminating water sources and accumulating in the food chain.
Section 4. Tiny sentinels, biological indicators. While physical and chemical parameters provide valuable data, biological indicators offer a holistic assessment of water quality. By studying the presence, abundance, and health of aquatic organisms, we gain insights into the overall health of the ecosystem. Microorganisms like bacteria and viruses are particularly useful indicators of fecal contamination. Their presence signals a potential health risk, as they can cause waterborne diseases. Algae too play a role. Excessive algal growth, often triggered by nutrient pollution, can disrupt the balance of aquatic ecosystems and lead to oxygen depletion. Macroinvertebrates, the small creatures that inhabit the bottom of streams and rivers, are particularly sensitive to changes in water quality. Their presence or absence can indicate the presence of pollutants even at low concentrations.
Section 5. Guardians of Water Monitoring and Regulation. Water quality monitoring is crucial for identifying pollution sources, assessing the effectiveness of mitigation efforts, and ensuring compliance with environmental regulations. Regular monitoring provides the data needed to make informed decisions about water resource management. Data collected from monitoring programs helps identify pollution hotspots and track the movement of contaminants. This information is essential for implementing targeted interventions, such as upgrading wastewater treatment plants or reducing agricultural runoff. Environmental regulations play a vital role in safeguarding water quality. By setting limits on the amount of pollutants that can be discharged into water bodies, regulations help prevent further degradation and protect human health. Monitoring data is essential for enforcing these regulations. By demonstrating compliance or identifying violations, monitoring ensures that industries and individuals are held accountable for their environmental impact.
Section 6. High-tech watchdogs, modern monitoring solutions. Advances in technology are revolutionizing water quality monitoring, making it more accurate, efficient, and cost-effective. Remote sensing, using satellites and aircraft, allows us to monitor vast areas of water, identifying pollution plumes and algal blooms from above. Automated sensors deployed in rivers, lakes, and reservoirs provide continuous real-time data on various parameters. These sensors can detect changes in water quality instantly, enabling rapid response to pollution events. Data loggers and telemetry systems transmit this information wirelessly to central databases, allowing for remote monitoring and analysis. This real-time data access enables swift decision-making and facilitates proactive water management strategies. These technological advancements are empowering scientists, policymakers, and citizens alike to become better stewards of our precious water resources. By providing a clearer picture of the challenges we face, technology paves the way for innovative solutions and a more sustainable future.